Hi, everybody. So today we're going to review for chapter 8.3 homework. And I think this is going to end chapter 3 for us, and chapter 8 for us. And I think we are at the end of the semester. So please check out your syllabus, your timeline. So let's start. So for the questions, the multiple choice questions, you can look at the key. All right, for the multiple choice questions, you can look at the key. I will circle the ones that I think that we need to work together on. This one, for example, for number 3, they already set up uh, the uh, the claim for you guys. It's already here. So these are pair t-test, and your claim is HA mu d is less than 0. So this guy should be mu d greater or equal to 0, but your claim is in the alternative. We already know. They gave you your sample statistic, so your D bar, your SD, this represents your standard deviation. And this is the mean pair, right? The mean pair data, the mean from your pair data values. And this is your sample size. Pretty simple. So here we have a less than, a left tail test. So our choice should be here, B. That should be our choice. Now, what is the test statistics? Just so you know, all of this can be programmed in your calculator. So this specific work, you know that from looking at the notes from the chapter, is that a pair t-test is the same as if you have just a one sample t-test. Those two are similar. Those two are the same. So I can program that information inside my calculator. So I will show you how I do that. I'm going to show you my screen. So we're going to go inside the calculator and enter that information where, let me jot it down first for everybody. We're going to go to Stat, Test. We go to t-test. T-test. And you select stats. And mu 0 is just going to be 0. X bar, you're going to put 1.8. S of X, you're going to put 3.7. And then N, you're going to put 19. That's literally what you're going to do. I'm going to show you my screen. So I'm jotting down X bar is 1.8. SX is 3.7. N is 19. And then it's a less than test. So this is what we have. This is it. So this is what you enter. Literally, this is what you enter inside your calculator. It's a t-test. And once you do that, then you just go to calculate. And it gives you your test statistic, which is here. There goes your test statistic. This is it. So now what do you see? Your test statistic is going to be 2.12. Says round to 2 decimal places. It's right here. Critical values. Alpha is 0.05. So this is a left tail test. So it's on the left right here. So your alpha is 0.05. So you're looking for this critical value. So the way we get this guy, we just do inverse t, 0.05. Your n is 19, so degree of freedom is 18. You need a degree of freedom n minus 1. N minus 1. So your degree of freedom is just 18. That's what you plug in. I hope everybody is on the same page as me. So we got a second function, distr, inverse t, 0.05, 18, and then we press enter. So this is it. So there goes your critical value right here. This is your critical value. So your critical value is 1 on the left, negative 1.73. Now, since your test statistic, so now literally it's a matter of figuring out, okay, negative 1.73, my test statistic, we're going to have that in blue. That was what? 2.12. So your test statistic is somewhere right here, 2.12. Right? So since your test statistic is not in the rejection region, right? It's not in the rejection region. We are going to fail to reject the null hypothesis, and we're going to conclude that there is not enough evidence to support the claim. That's it. This is number 3. As simple as that. This is a pair t-test is the same as a one sample t-test. If you can do 3, you can do 4. Okay. Now this is a 2-tail test, so that's the only difference. But you can do 4 on your own. So I'm going to say you do this on your own. And the only difference is that you're going to have 2 critical values. Remember that. This is using a p-value, right? This is using the p-value method. Again, it says you have paired data and they give you the claim. So notice what the claim includes an equality sign. So this is your claim right here. So the claim is in the null. There goes your alternative, right? But everything else is given to you. You have your alpha, etc. If it's the p-value method, we don't need to look at any critical region whatsoever. We just need to look at the p-value. So here, mu d is greater or equal to 0, less than, this is a left tail test again. So our choice should be E. Let me make sure, oh no, not E. Should be D. This is our choice. Now we're going to still go and program this in stat, test, select t-test, yes, and we enter all that information. I'm going to show you my screen once I enter all the information. Stat, test, t-test, we have stats, mu 0 is just 0, yes. X bar is going to be negative 2.3, S of X is 1.3, N is 16, and this is a left tail test. So this is what you see. When you program that in your calculator, this is what you should have. So, and then you just press calculate after that. I'm going to make sure to send you my notes. Make sure you calculate after that. And there goes your p-value. Now, notice that your p-value is in scientific notation. I needed people to realize that the p-value is in scientific notation. It's 1.88 times 10 to the negative 6. So when it looks like this, your p-value is 1.88 times 10 to the negative 6. It means that this is 0.000. You have about, what, 5 zeros before you even get to 1. So it's almost 0. So let's look at first the t-statistic. There goes your t-statistic, negative 7.08. Round to 2 decimal places. The p-value is almost 0, 0.003 decimal places. So this is it. This is 0. Now, your p-value is definitely less than your alpha. So since the p-value is less than or equal to the level of significance, you're going to reject the null. We already know that we're going to be rejecting the null. And we're going to say, since we're rejecting the null, then remember where the null is, where the claim is. The claim is in the null. So what you're saying, you're rejecting that claim. Are we on the same page? You're rejecting the claim. So there is statistically significant evidence to reject the claim. That's what we're saying. And and that's that. So this is your p-value method. This is your p-value method. It's a matter of rating your output properly. Rating your output properly. All right, let's look at 6. Now here you have data, okay? So I need everybody to pay attention to this little number here. We have data here, so it's interesting, all right? So it says the table below shows the number of hours per day 11 patients suffered from headache before and after 7 weeks of soft tissue therapy. Remember, you have dependent data. So your samples are random, they're dependent, population is normally distributed. These are all conditions for a paired t-test. I hope everybody's following me. These are all conditions for a paired t-test. So is there enough evidence to conclude that soft tissue therapy helped to reduce? So this is before the treatment, this is after. So there should be a reduction, right? There should be a reduction. Help to reduce the length of time patients suffer from headache. So to reduce means your mu, imagine this is mu before and this is mu after. So mu before has to be definitely, right? Mu before has to be definitely greater than mu after. That's what I'm saying. Because you have a reduction. It has to be greater. So whenever you're looking at the difference between the pairs, because this is literally what we're going to do, we're going to look at the difference between the pairs. We are saying that mu B minus mu A, right, is going to be like so, greater than, your 0. Whatever, that 0 is going to come here. So the difference between the pair has to be greater than 0. This is what we're saying here. So this is how we set up. This is how we set up the null and the alternative. In this case, the alternative. So in this case, what I'm saying is my alternative should look like this. Mu D greater than 0. Of course, the null is going to be mu D less or equal to 0. So this is the null and the alternative. If you need to pause the video to get it, if you need to pause the video to understand what I just said, pause the video and pay attention to what I'm saying. Now, in 8.1 and 8.2, the way we set up alternative and null was a bit different. But because you're looking at differences between the pairs, when you're talking about reducing, you're saying that the average daily headaches before the treatment is going to be greater than the average daily headache after the treatment. So this is what you're saying here. But since we're looking at the difference between the pairs, so literally you're subtracting mu A from mu D, yes, and that becomes greater than 0. So that difference is greater than 0. So this is your alternative, this is your null. So the choice here that you should pick is, let's say, it should be F. And I'm going to give you a little trick, and I will say that again when I see you guys in class. I will say that again. In the pair t-test context, when you see reduce, less than, or anything that is in that verbiage, what we mean by that is that HA is mu D greater than 0. But if you see something like greater than, or more than, or exceed, if you see anything in that verbiage, it means HA has to be mu D less than 0. That's what I'm saying here. This is for pair t-test context. Pair t-test context. And I'm going to talk about it again when I see you guys during the Zoom live. All right, I will talk about it again. So what we're saying is that the therapy reduce the length of time patients suffer, right? Reduce, what choice do you have here? Helps reduce. So this is it. Helps to reduce the length of time patients suffer headache. And I showed you exactly how we came about, setting up the alternative hypothesis. And I told you again that whenever you're reading a problem about a pair t-test, look at the keyword. If you see something like a reduce, less than, anything in that verbiage, you should know that your HA is mu D greater than 0. But if when you read the claim, you read something like greater than, more than, exceeds, increase, right? You should know that HA is mu D less than 0. Okay. If you need to pause the video, go back again and listen to what I said, do so. All right, let's start. So the first thing we're going to do is we're going to go to Start, Edit. In L1, we're going to put this guy in L1, and then L2 is going to be the second row. So let's go to Start, Edit, and I'm going to show you my screen. Take your time to put in that data. I'm going to put in the data. Take your time, put in the data. Once I put in the data, then I'll show you. All right, so I'm gonna go and check now. 1.3, 1.1, 1.3, 1.5, 1.5. Then I have 1.6, 1.4, 1.2, 2.5, then 2.9, 4.2, 3.1, 3.2, 3.8, 2.2, 4.3. All right, I have my data in. Okay, so I'm going to show you my screen now. Once you have your data in just like this, okay, the next thing you need to do is create a third column. We're going to call it L3, where we're looking at just the pair data. So highlight L3 just like you see me highlighting. You highlight L3, and then you go to second function, L1 minus second function, L2. And you press enter. Oh, shoot. Don't make a mistake. Whoop. There we go. And then you press enter. This is what you're going to have. That's the data you want to use. That's the data you want to use. That's the data you want to use. Go back till we get on the same page. That's the data we want to use. Okay? Enter the data, and then L3 should be L1 minus L2. So L3 should be L1 minus L2. That's L3. Now, this is a left tail or right tail test. This is a right tail test. So the rejection region is on the right. My alpha is 0.01. So this guy is 0.01. Okay, so it's inverse T. This entire side here is 1 minus 0.01. So 1 minus 0.01. This is 0.99. Remember, we enter the area to the left, 0.99, and then we enter the degree of freedom. How many patients do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So my degree of freedom is n minus 1, 11 minus 1, which is 10. So this should be 10. So when I put that in the calculator, second function DISTR inverse T, 0.99, 11, oh no, 10. Paste, enter, enter. So this will give me my critical value, and I'll take a picture of that and show you. Here we go. So there goes my critical value right there. See? So you enter, say, around to how many decimal places? 3. 2.764. Now your critical value is right here, greater than. So find it. Should be D. So far, so good. Now they want you to find the mean pair data, the SD, the t-test. Once you have all the data inside, just like me, everything becomes easy because you go to stat, test, t-test, right? I'm going to show you guys my screen. So stat, test, t-test. We don't have stat, we have data. So go and select data. And now your mu0 remain as such. Now you have L3. Remember where your data is, yeah? Enter L3. L3 is second function L3. And it's a greater than. Boom. Here we go. So this is how you set it up. And then you press calculate. Then you go ahead and press calculate. And you get the everything you need. Once you press calculate, it gives you a lot of information. It's going to give you, number one, your pair data, your mean pair data, which is here. So 1.27, 3. Then it gives you your SD, which is here, which is going to be 0.693. Then it gives you your standardized statistic, which is here, 6.092. That's that. And then you're going to see where you go from there. Do we reject? Do we fail to reject or no? So I'm going to graph that again. Your critical value is 2.764. 2.764. This is your critical value. Now, your statistical test is somewhere here at 6.092. So it's within the rejection region, so we reject the null. See? As simple as that. And once we reject the null, remember your claim was in the alternative. Once you reject the null, then we have enough evidence to support the claim. So at the 1% significance level, there is enough evidence to conclude that soft tissue therapy helps to reduce. Yep, the choice should be D. And that's it. This is a very, very important exercise. If you have to pause the video, look at the way we did this over and over. Do it, do it, do it, do it. Especially the way we set up the alternative, okay? So I'm going to put an asterisk here for you to do that over and over. All right, so let's move on. Now, see, this one, I'm just going to look at the claim and tell you how to set up. It says, a scientist claims that causes weight loss. See, weight loss. So reduction. As soon as you see weight loss, reduction, yeah, people, you already know mu D has to be greater than 0. So you know. Weight loss, reduce, less than. So I have to move on. You guys can do 7 on your own. Yep, you can do 7 on your own. Let's look at 8. An instructor for a test preparation course claimed that will improve Improve means increase. Yeah? It means that the score on the first test should be less than the score on the second test. So if it's improve, it means that HA has to be mu D less than 0. HO has to be mu D greater or equal to 0. And this is where your claim is at. I hope everybody is following me. So it means that your critical region should be on the left side. Okay? Should be on the left side. And the way you pick this guy here should be, yep, this should be how you pick this guy. I'm not doing it because I did 6. Once you do, I did 6, you could do 7, you could do 8. I'm just showing you guys the keywords. All right. Critical region is on the left. Everything else, your calculator helps you do that. Let's see. A physical therapist claims that 1 600 milligram dose of vitamin C will increase. Yeah? Increase. And then it gives you the table. It says table available below shows the number of repetition for 15 mLs until the grip strength in 3 where 50% of the maximum grip strength. So increase. We already know if it's increase, it means this is what we have here. All right. This is increase. So you can do 9 on your own. You enter the data and you go about calculating everything else. I think that the only issue you may have is once you know how to set up your alternative and you know, then it's entering the data properly. So take your time. Here, increase. A reporter claims that U.S. gasoline prices increased from May to June. If it's an increase, it's a less than sign. And we know how to do that. This is the same work over and over and over again. They gave you the condition samples, random and independent. Populations are normally distributed. Enter the data and work on it. Let me see. Okay. Now this is a two-tail test. I'll do this one. Now 11, it says this. It says a company wants to determine whether its consumer product rating 0 to 10 have changed from last year to this year. So what we have here is mu D different than 0. This is what we have. This is your claim. This is a two-tail test. The null is mu D equal to 0. So have changed. So look at the choices from down below. Changed. That's it. So we have a two-tail test. So our choice should be this, B. If it's a two-tail test, we already know we split the alpha in 2 for the critical region, yes? So this should be alpha over 2, which is going to be 0.025, 0.025. So my critical values, they come in pairs, yes? So my critical value here should be plus or minus, but at least we know it's inverse T, 0.025, area to the left, 1, 2, 3, 4, 5, 6, 7, 8, 8 minus 1, degree of freedom, 8 minus 1, it's giving me 7, so 7 should come here. So I'm going to show you my screen. Second function DISTR inverse T, 0.0257. So we have a plus or minus here. So the choice is plus or minus 2.36. I hope everybody sees that. Here we go. So we already know it cannot be A, cannot be B. Yeah. But notice that they were already giving you some, like, this is a little trick because they realize that if you don't split the half in half, you're going to make the wrong decision. So this is your choice. So this is negative 2.36. This is positive 2.365. So those are your critical values. So you're going to enter them: negative 2.365, 2.365. I think that's how you guys do that. The next thing we do is we're going to put this guy in L1, L2. We create L3 as L1 minus L2. So go ahead and enter that. I'm going to show you my data in a minute, but let's go ahead and do that. Enter your data. And let's come back. Let's give ourselves about a minute. Pay attention to the way you're typing things in. And take your time. All right, I'm going to show my screen. So this is my data, L1, L2. L3, go up, highlight. You need to highlight. Go down, take L1 minus second function L2. Just like this. Then you press enter. This is what you get. Once you have the same thing as me, you come back in. Pause your video if you need to. Once your data is in, remember, we get all of this information from doing the test itself. So start test, you go select t-test, and that's what you need. So I'm going to show you my screen. Start test, t-test. Yes, you have data, okay? And everything is the same, but here we have a two-tail test. Calculate. That's what you need. All right, let me show you my setup again. T-test. I'm going to take a picture of that. Once you have this picture, take the picture of, I'll show you my calculate. Here we go. This is it. We have this crop. Now we can talk. Now we know what D bar is, which is your X bar here. And that's 0.625. S of X, this is your D bar, this is your SD. Round 3, 0.916. Your T statistic is right here. T stat 930. That's it. Now notice, where does your T falls? We're gonna have that in blue. 1.0 right here somewhere. There goes your T stat. So it's not inside the rejection region, so we failed to reject the null. If you fail to reject the null, then the claim, we don't have enough evidence to support the claim. Okay. All right, so interpret the decision in the context of the original claim. So we failed to reject the null. At the 5% significance level, there is not enough evidence to support the claim that, is C. This is it. That's it. So this is an example of a two-tail test. Okay? Using the critical value method or critical region method. Pause, review. Okay, so let's look at two to support the claim that the paths have changed. So, see, I did 11, you can do 12 on your own. Have change. So, two-tail test. Let's look at 11. Food manufacturer claims that eating a cereal as part of lowers Mu D has to be greater. That's what lowers means. Lowers, that's the claim. You can do this on your own. It's using the p-value, so it should be easy to do. Using the p-value, you guys can do 13 on your own. Let's see. 8, try to lose the highest percentage of weight in order to win. Oh, okay. So, try to lose the highest percentage in order to win a cash prize. As part of the show, the contestant have time as they run. Table shows at the beginning and at the end. Is there enough to support the claim that the contestant time have changed? It's just have change. Have change. So it's a two-tail test, I believe. If it's just have change, it should be a two-tail test. Yeah? Have changed. It should be a two-tail test. So my choice should be right here on B. You can do this on your own. Let's look at 15. The passing play percentage, Is that the claim that passing play percentage is different from, it's a two-tail test again. All right, you can do this on your own two-tail test. 16, and now 16. I'll do this and that'll be the end for me. So now you have a sleep disorder specialist that wants to test the effectiveness of a new drug that is reported to increase the number of hours of sleep patients get during the night. To do so, he selects 16 patients, records number of hours. He wants to construct a 90% confidence interval. This is the confidence interval. Just so you know, this is the same thing as a T interval, and we saw that in chapter 6. This is the same as a T interval. What we do is we go into stat, edit, and then we enter this in L1. This guy goes in L2. And then we create L3 where we enter L1 minus L2. And that's what we work with within the calculator. As simple as that. So let's go ahead and let's do that really quickly. Okay, let's enter the data first. When you enter the data, be careful, okay? Let's enter the data properly. Start, edit. L1, enter the second row. L2, you enter the second row. Let's come back. In L2, we're going to go ahead and enter the second one, or the third row. All right, so everybody should have everything entered. So I'm going to go back and check. I'm checking my work just to make sure. And then the next one. Okay, I have all my data in. I'm going to show you my screen now. All right, so there goes the data. We go up and we do L1 minus L2. We know how to do that. second function L1 minus second function L2. This is what you have. Press enter and we take a picture of that. Come back. Okay. Now that you have your data in, we go back to stat, edit, or stat test. And we go, let me show you my screen. You go to stat, test, you go to T interval. Now you have data, L1, 1. Was it a 90% or was it a 95%? Can't remember. 90%, 0.90, so this should be it. And then you press calculate. When you press calculate, I'll show you my results. This is what we have. So there goes your T interval, just so you know. There goes the T interval, and we're good. So when it says calculate D, confidence interval, what is the confidence interval? This is what you have here. So my confidence interval, round to 2 decimal places as needed. It's negative 1.56 to negative 1.14. That's it. End of the story. Okay, so I'm gonna post this video right now, post my notes, and go ahead and complete your CH 8.3 homework. See you on the next Zoom. Bye, everybody.